when you have an electric hot water heater, it's one of your biggest draws. Or well done. Electric hot water heaters are a big draw on the grid system. So NYSERDA wants to basically try to reduce demand on the grid, and this is one way to do it. So they offer a very attractive rebate. It's $4,000 per system. That comes right off the top of your purchase price, and I'll get to a slide here later that shows that. So it's a very, very attractive incentive program for solar thermal. And again, solar thermal is relatively cheap to begin with compared to photovoltaic. So it just makes that even a better buy for you. This is just a schematic showing you just what the components of the system are. You can see you've got the panels on a roof, you've got the piping that is drawing what's called a heat transfer fluid. It's basically propylene glycol down into your basement where there's a pump and a controller system, feeds into your solar hot water tank. The tank it basically transfers that heat through piping, and then the depleted heat transfer fluid flows back up into your collectors, and it starts the process all over again. And it basically runs. It's all carefully controlled by that gizmo that is to the right of the tank, and it's a very intelligent system. There's nothing that you have to do on a day-by-day basis to keep this thing running. It's all carefully monitored with a very smart pump controller. These are just some of those components. Again, I'm going to move along rather faster because I got like 30 slides, so feel free to just come up to me afterwards if you have specific questions. These are the components. This is what's called a one tank application. You can have other different setups, but this is just one tank. The fluid goes into the hot water tank, heats up, and then goes back out. Here's a 2-panel system, which is what I have. That is sufficient for hot water demand for most people. People who want to do additional things with the solar thermal can go to 3, 5-panel, or even more panels. And basically, those additional panels can be used to provide radiant heating in your house, as well as meeting your hot water demands. So you can basically put radiant piping in your floors and have your warm floors basically heating your house. That is not covered by the rebate program. So you would obviously run a much greater expense if you're going to do something like that. And it would also only apply to new construction. So here's my house. This was actually the day of or the day before that they started to install the panels. And they're installed to the left of the front door there. Here are the components again in a little more detail. And here's what it's looked like before it's installed. A lot of cardboard. Hopefully it got recycled. And here's the guy starting up on the roof. This was on or about April 27th, 28th. I think there was a hawk in the tree over there that was watching this very carefully for quite a while. So they prepped the roof, and they installed the panels. And here's a little video I'm going to run. Let's see if this works, showing them hoisting the panels. Didn't work. How do I go back? Shift tab? Just up arrow? Oops.
I didn't see any animation.
Is there a cursor? How do I get the cursor?
I think you better be
Let me just try this one more time. Anyway, that's a little movie showing them hoisting the panels, which apparently is not going to work. But they did get it up there successfully. Nothing crashed to the ground. So this basically took all day. There's basically 2 days of installation. The roof guys worked the whole day, and then a third guy came in on a separate day and installed the piping for the heat transfer fluid down from the roof through the attic, through the house, and then installed all the components in the basement. So there was probably about 3 days of actual work involved in getting this thing running. Oops, the wrong way. And there's a close-up of the collector, basically showing how the fluid moves through the collectors. Basically, it's taking the heat and bringing it downstairs into the tank. This shows you a little more about the actual construction of the collector panels, if you're interested in those kinds of details. Velux systems are made, I think, in Denmark. They're made in Europe, so I can't say it's made in the USA. And here's a close-up photo of the panel, and this is what you see if you get up on the roof and you look at it. And here's your tank again. The tank on the left is the electric tank setup. The one on the right is the boiler setup. If you have a furnace, you know, you're using gas or oil. Obviously, the one on the left is the only one you're going to get the $4,000 rebate for. And here's a shot of the tanks in my basement. This is the setup. That's the 80-gallon tank. You can see that. Let's see if I can get this thing to work here. There's your pump controller. This is referred to as a line set. This double set of lines. So this is coming from the solar collector. That's your heated transfer fluid, and then the depleted cooled fluid comes back out, and it's all pumped continuously between the tank and the roof. And here's a picture of the line set in the basement. It's snaked alongside the main beam, and then it's popped up through the basement ceiling, and it is cleverly routed through the inside of a closet, so you don't see it. That's the inside wall of a closet, and I apologize for my choice of wallpaper. I call it the fern room. Alrighty. And here's some of the components again. That's not your everyday antifreeze, by the way. That's a specially designed antifreeze solution for this purpose. And collector temperature sensor. Am I doing okay time-wise?
No,
Move around.
You're about there.
Okay. Basically, this thing needs to know how hot the collector is, so that's your temperature sensor wire. Here is basically how this thing works as far as storage tank, collector temperature, bringing it up to the collector temperature, then shutting it off. Here is the pump controller, the brains of the system. You don't really have to do anything. This does it all. And here's the bottom line. Basically $10,000, that's about what it costs. $4,000 right off the top. I wrote a check for $6,000. I'm gonna have a very nice tax return next year because all this stuff comes off of my taxes. There is basically a tax credit of 30% federal and a 25% New York State tax credit, leaving me with a net cost of $1,500. That is very, very attractive. Let's get into payback here. This is what I came up with as far as my payback period. I sat down with my electric bills and tried and figured out what my electric here costs me on an annual basis, and I had some different scenarios there, running from 100% to 50% of my nighttime electric demand because I have a day-night meter. And so those scenarios run from about, payback periods run from about 4 years to 7 years to get back what the system is costing me. And there's more information available if you want to contact the installers, the rating store in Malta, in the Saratoga Energy Technology Park, myself, and the NYSERDA rebate program. They'd be glad to talk to you. And as far as I know, I checked with them yesterday, they still have scads of money. So go for it.
Thanks, Tim. I didn't see any hands go up.
Any questions? Yeah.
How long would that water heater, how long is that expected to last?
All the components, I think there's different warranties with different components. I think the solar tank itself has a 10-year warranty on it. And, but I can get you that information if you want. Basically, all the components are warranted. Some components have a longer warranty than others.
You said your payback period was 5 to 7 years. Are you talking about the 1,500 or the 10,000?
Basically, my net costs. My net cost, what is out of pocket for me.
Okay.
That $1,500 line is what I'm shooting for in terms of a payback.
Okay.
Okay, I am the ringer in the group. I did not buy this shirt on eBay. I am actually a NYSERDA employee, and I currently head up our wind incentive program. About 4 years ago, a position opened up to head up both the PV and the wind incentive program at NYSERDA. And at that time, our family came into a little bit of money, and I told my wife this would be a good opportunity for us to buy a PV system and put on our house to really show NYSERDA management that it's something I'm very interested in. She said I would rather have a second bathroom, so I do not have a renewable energy system in my house. If you're looking for a wind turbine and you want to put one up, there's really only one reason that you should do it. And if you're really looking for a system that's going to be easy, that you can install and walk away from, wind turbine is not that system to do it. You have to have a passion for it. And I've talked to people who have told me from when they were a little child, they've always wanted a wind turbine. And these are the people who are going to make it successful. I've had PV installers tell me that their goal is to never see their customer again. In a wind system, that will not be the case. You will see that installer at least probably once a year for the next 20 years. So I guess be sure if you're going to work with an installer, work with somebody that you're going to want to have that long-term relationship with. Again, this is a moving piece of equipment, just like your car, it needs maintenance. So if you remember back in second grade, wind is moving air caused by the uneven heating of the Earth's surface. The second quote is one I really like that I just saw where it says, wind is recycled solar energy. So if you're really thinking of doing something extra good, here you can say that it's solar energy and it's also recycled. So that kind of makes it a double positive thing. It's important to realize that all generators like clean fuel. And for a wind turbine, that is the wind. And if you've ever been in a plane and experienced turbulence, you know that turbulence is not good. Some manufacturers will tell you that their turbines perform very well in turbulence. I would beg to differ with that. And again, doubling the wind speed, 8 times the amount of power. That's a very important, critical fact, and we're going to hit on that a couple times. Like I said, turbulence is bad. This is what's called a turbulence bubble. Whenever there's anything in the way of the wind, it will create turbulence after it and a little bit before it. And as you can see here, it's twice the height, and that can extend for 20 times that. If you look at the guy flying the kite and you see the streamers, outside the streamers, really nice clean air, clean wind. Inside the bubble, you can see that it's just a lot of recirculation, just not a very good spot for your wind turbine. You want to make sure your wind turbine is outside of that bubble. Taller is always better, and if you like things that rhyme, the more tower, more power is a nice, easy way to remember that. Although it's not always economically best to keep going with a taller tower, and this is with wind, the higher you go, the more wind speed you have. Certain areas that has a sharper shear, so meaning the wind speed goes up much faster. Other areas, like if you're out in the plains in the Midwest, you don't gain that much wind speed as you go up. So you almost really want to look at your site, what's the wind characteristics, what's that additional cost of going up another 20, 40 feet, and will that extra cost give you that enough power to make it worth it? I'm going to say typically in New York State, yes it does. Buy the tallest tower you can possibly afford. Here's a map of New York State and a number of turbines that we funded. You look around the Capital District, you see that there's not very many around here. And that's really because the best winds you're going to see are along the lakes in the Finger Lakes region. We have some down in Taconics, southern Columbia County, northern Dutchess County. And again, you really have to look at where the wind is to really make sense at where you want to put your turbines. So our program, to sum it up, is really the first sentence. We offer incentives to qualified equipment installed by eligible installers. One of the nice things is we say that there is no paperwork for customers. Although the current program is expiring the end of the year, we do have funding to 2015. I don't suspect a real big change in the program over next year, at least not on the residential side. We do currently have 32 turbines on our list, and these range from about 1 kW up to, I think 275 is the largest one on the list right now. We include what's called the AWEA capacity rating. AWEA is the American Wind Energy Association. They have set a standard for rating turbines. Before that time, there was no standard, so basically manufacturers were free to call something whatever they wanted to. And we also include the rotor size, and that's important because that kind of gives you an idea of how much energy it's going to produce. And that last claim I have there, that yes, there are turbines that will generate at a very low wind speed, but if you look at the power curve, they're going to be generating a very little amount of energy. Our program works so that we actually base our incentive, instead of being a flat fee like the solar hot water, it's based on your expected production. Whereas, so up to 10,000 kilowatts, it's $350, and then it's declining blocks after that. We do cap it at 50% of the cost. A critical fact is that you need local approval, and this can be the most challenging. I've had one installer tell me the most difficult thing about installing a wind turbine is getting permission to do so. The easiest thing is actually installing it. There was a one-town board out in the western part of the state who said that wind energy and cell towers are now part of our fabric. I thought that was a great statement, and I think it really looks to the future, but there's many communities that that is not true. Actually, I'm just going to go ahead one here. We're going to come back to that slide. I want to say, what do I tell people to start? So the first thing you should do is see what your wind resource is. And at this website, you can put in your site. The second most important thing is, will your community allow you to install one? Do you have a local ordinance pertaining to wind turbines? And of course, contact multiple installers. So let me get back to, so this is the Small Wind Explorer that you can look at. I picked NYSERDA's parking lot. And as you can see, this is not a very good site. It's listed as poor. But what is nice, it gives you the direction of the wind. And you can see here most of the wind is coming out of the northwest and west and at the south. So if you are at that site and you look around, if you see a lot of obstacles in those directions, you'd probably say, well, this is not a good spot to put up a wind turbine. If there's obstacles to the east, to the northeast, you really don't care about those so much, because they're going to be on the backside, not in a critical spot. Now, on this one, if we went up higher, this gives you at 3 heights, and this is a customer report that any of you can run, and it goes up to 120 feet. Here, if probably we went to 140 feet, and you probably can't read that, but at 120, I think it's about 8 miles an hour, which is right on the verge. But if you go up another 20 feet, you're probably up to 9, maybe up to 160, you can get up to 10, and now you're getting enough to make a realistic shot at generating energy. So, okay. So here's some pictures. This is a Provin 15. This is at an apple orchard. What I liked, I thought the installer did a great, also this is a downwind machine. So as you see it there, the wind would be at your back when you're looking at that turbine. If you look at all the components there, they're installed on the backside of a cold storage facility. I just thought they did a real nice job of laying all that out. And that is a freestanding tower there. Wind and PV do play together. The only reason I went to this site is because it's actually on Bird Cemetery Road. And I figured, what a perfect spot for a wind turbine. So I didn't even know the PV panels were there. I just wanted to take a picture of it because of its location. And again, if you look at the performance of PV and about wind, it's really a perfect marriage. Wintertime, you have the stronger winds. It's when the wind system is generating. Summertime, you have the PV system kicking in. You do want to make sure that you don't have, although in this case, you can see that the wind turbine is to the south of the panels. I believe it's far enough so you're not going to have the shade of the turbine falling on the panels. This is a Berge. This is manufactured in Oklahoma. It's a 10 kW system. It's a farm in the Finger Lakes. This is kind of the workhorse. Probably 80% of the turbines I see, applications I see, is for this turbine. It's just a real nice machine. It's probably not the biggest performer, but it does do a nice job, and it's a very low maintenance machine, which is a very positive thing. So it's going to be there and generate for you when you need it. Fortis Elise. And again, this is another residential application. Also a nice little turbine. The Skystream, this is manufactured in Arizona. This is another downwind machine. This turbine does perform very well on turbulent areas. There's actually mounted on, they have one on top of the Boston Museum of Science. If you're really interested in building mounted winds, make a trip to Boston to see their exhibit that they have there. It's definitely worth it. This is a small machine.